Israel's Iron Dome defense has literally been the difference between life and death in their war against Hamas. However, an even more advanced defensive network is waiting in the wings. While the Iron Dome has demonstrated its effectiveness on numerous occasions, that heralded system might take a back seat to the high-tech power that is the Iron Beam. Also known as Light Shield, the Iron Beam is a laser-based air defense network that can obliterate short-range rockets, mortar bombs, and artillery. Not only that, but it can also fend off unmanned aerial vehicles, UAVs, a tactic Hamas has been relying on more than ever. And the price of each laser fired is negligible. According to many estimates, it only costs Israel $2,000 per shot to utilize this technology. Given the potency and economical design of this emerging warfare wonder, it's easy to see why many consider it superior to the iconic Iron Dome. Some go so far as to say that it will completely replace the Iron Dome. But can the Iron Beam deliver on its promise? To answer this, we need to compare the technologies side by side. Let's start with the older of the two, the Iron Dome. Released in 2011, the Iron Dome has been a staple of Israel's defense tactic for more than a decade now. It's a sophisticated system of detectors and rocket launchers that intercept enemy missiles. The technology is made up of three elements. The first element is the radar. When a hostile launches a missile at Israel, up to 43 miles away, the Iron Dome identifies it and gathers data on the projectile's trajectory. The second element is a computer. The computer receives the information from the radar and calculates where the missile is going. Figuring out the destination of a ballistic missile is relatively easy since it's fairly predictable. That's because ballistic rockets generally fly on an arc. If you can identify the arc, you'll get a pretty accurate idea of where the missile is supposed to strike. That's exactly what the Iron Dome computer does. The third element is the launcher. If the computer determines that the missile will hit a strategic or populated area, it sends Tamir interceptors to collide with the projectile mid-air. If the missile can't be intercepted, the Iron Dome allows it to reach the designated location to save interceptors for future use. The ability of the Iron Dome to protect civilians and military strongholds is being put to the test as we speak. Ever since the beginning of the most recent assault by Hamas, they have launched thousands of rockets that targeted heavily populated areas. Thanks to the Iron Dome, the vast majority of them failed to reach their destination. But this isn't the first time the Iron Dome demonstrated the might of the Israel Defense Forces, IDF. It's protected the nation from projectiles throughout the 21st century. However, that's just scratching the surface of the Iron Dome's influence, history, and technological prowess. It might tell us if the Iron Beam is an addition to their arsenal or a full-blown replacement. The first instance of the Iron Dome being used in combat can be tracked down to March 2012. It was at this time that Gaza terrorists launched a major missile offensive on southern Israel, discharging approximately 200 projectiles in under 3 days. Hamas operatives thought they had caught the IDF off guard, but the Iron Dome proved them wrong. The system calculated that most of the rockets were headed toward unpopulated areas, which would result in no casualties. However, the Iron Dome intercepted more than 50 rockets that targeted Ashkelon, Ashdod, and Beersheba. If not for the Iron Dome intervention, there's no telling how many innocent lives would have been lost. It didn't take long for the Iron Dome to react once again. In November of the same year, Hamas launched another airstrike that included over 1,500 projectiles aimed at Israel. The Iron Dome intercepted about 400 of them. The vast majority of the remaining rockets were deemed harmless. The defense was executed hand-in-hand with the IDF's Operation Pillar of Defense, which aimed to lower the number of missiles Hamas could use to besiege Israel. 2 years later, the Iron Dome was under immense pressure yet again. This time it was Tel Aviv and Jaffa that the system had to safeguard against Hamas rockets. At the start of Operation Protective Edge, Hamas targeted numerous densely populated regions of both Tel Aviv and Jaffa. Fortunately for the Israelis, the missiles proved no match for the Iron Dome, which intercepted around 700 rockets. The defense paved the way for a resounding IDF victory, resulting in 32 Hamas tunnels destroyed and hundreds of terrorists vanquished. The history of Iron Dome intervention doesn't end there. In May 2019, the Palestinian Islamic Jihad, PIJ, and Hamas teamed up to send nearly 700 projectiles toward Israel. Most ended up in open areas, resulting in no casualties. However, the Iron Dome also saved the lives of countless civilians by bringing down 240 missiles. The longer the conflict between Israel and Palestine goes on, the greater the intensity of Hamas's rocket attacks. This was on full display in 2021, when Hamas and the PIJ aimed to strike a decisive blow to the IDF by firing 4,350 projectiles at Israel. The number would be overwhelming for practically any other defense system, but not for the Iron Dome. Even though the intensity and number of missiles had been unprecedented, the Iron Dome didn't disappoint. It intercepted nearly 1,500 incoming projectiles that were headed toward populated and strategic military areas. The pressure from Hamas mounted when terrorists started launching missiles from various directions, but the Iron Dome proved to be an insurmountable obstacle. Over the course of this defense operation, the dome had a 90% success rate. However, this didn't discourage Hamas from launching additional assaults. The IDF knew it would need to upgrade its defense system even further and position the Iron Dome on multiple fronts. And so it did. In 2022, Israel announced that Sea Dome, the ship-mounted version of the Iron Dome, would soon enter the marine battlefield. The system passed several tests that showcased its ability to repel different threats that could emerge from the sea. In June of 2023, the IDF conducted another series of tests that proved Sea Dome's effectiveness at intercepting drones, cruise missiles, and rockets. Israel has already developed several Sea Domes on its SAR 6-class corvettes, small warships, to protect the country's shipping lanes, coastline, and natural gas rigs. By blocking the foe's projectiles from destroying their targets, Sea Dome should help ensure Israel's maritime superiority in the Mediterranean Sea and the Red Sea. Over the years, the Iron Dome has received numerous expensive updates to keep the forces of Hamas at bay. Israel's leading defense technology company, Rafael Advanced Defense Systems, invested billions to develop and keep the system efficient. The US also pitched in with approximately $3 billion allocated for interceptors, launchers, general maintenance, and many other aspects of keeping the Iron Dome in great shape. More financial aid from the US is in the offing. Specifically, President Biden recently announced that America would provide additional military assistance to support the Iron Dome. He's not the only one behind this initiative. Several members of the US Congress proposed a bill that would send Israel another $2 billion to reinforce the Iron Dome. With all this funding going to the Iron Dome, one can't help but wonder, what if there was a better, cheaper way for Israel to defend itself? This brings us to the other side of today's debate, the Iron Beam. If you think that laser weapons from Star Wars are improbable, the Iron Beam will prove you wrong. The system fires laser beams to topple airborne targets. Like the Iron Dome, it features a surveillance network that detects enemy projectiles before engaging them. As soon as the Iron Beam identifies a threat, it sends a laser that travels at the speed of light and reaches the missile before it reaches its destination. The IDF and Rafael didn't randomly decide to pursue such technology. The development started as a result of increasingly dangerous assaults by Hamas, who diversified their arsenal. They recently relied on UAVs and mini-UAVs, besides rockets and mortars, to threaten the Israeli military and general population. The Iron Dome proved instrumental in vanquishing these dangers, but it's also expensive. Each interceptor fired costs between $40,000 and $50,000. This might not sound like much if the Iron Dome fires just 2 or 3 missiles, but that's not the threat it faces in the war against Hamas. As previously noted, Hamas often engages Israel with multiple projectiles from different locations. Fired in quick succession, they force the Iron Dome to release hundreds or even thousands of interceptors at the same time. Not even the most powerful militaries can afford such costs in the long term. Rescue comes in the form of the Iron Beam. Using this system, the IDF can shoot down Hamas missiles for a fraction of the price of the Iron Dome. Each laser costs the Israeli military only about $2,000, including the price of technology development, allowing them to launch 20 to 25 lasers at the cost of 1 Iron Dome interceptor. If that's not a viable and affordable long-term defense strategy, we don't know what is. Another reason the IDF may replace the Iron Dome with the Iron Beam is to improve the efficacy of its defense tactics. The Iron Dome is highly effective, with a consistent 90% success rate across different operations. The extra 10% might not sound much, but even a single missile that bypasses the interceptors can wreak havoc on Israel and result in lives lost. The main reason the Iron Dome isn't 100% effective is that it's designed for small strikes. If Hamas launches thousands of rockets in a short window, the Iron Dome doesn't have the capacity to prevent each projectile from hitting its target. The Iron Beam, on the other hand, might just be the ace up the sleeve the IDF has been looking for. This technology features a power output of approximately 100 kilowatts. This gives the ion beam enough velocity to reach the rocket before it makes contact with the target. Since the technology is so fast, it can pick apart numerous projectiles in just a few seconds. What about the magazine requirements of the ion beam? This is yet another aspect where the ion beam excels. Given the laser-based design of the technology, there's no need to reload the weaponry. The fiber laser generator constantly fuels the ion beam, meaning it can never run out of ammunition, as long as the generator is operational, of course. The same cannot be said for the Iron Dome. Although advanced, it still features a traditional magazine design that requires consistent manual reloading. Hamas troops can seize that break-in activity to bomb defenseless cities. This won't happen on Iron Beam's watch. What's also impressive about the Iron Beam is that it reduces the debris caused by intercepting enemy missiles. Traditional rocket defense systems tend to result in lots of debris, and it's easy to see why. Just picture two rockets slamming into each other at dizzying speeds. The energy released during the process is almost unfathomable, so imagine what this energy does to the two missiles. It scatters them into thousands of pieces, all of which turn into mini projectiles. They can't harm buildings and other structures, but rogue shrapnel can prove lethal to civilians trying to hide from the commotion. The Iron Beam is a real game changer in this respect. Rather than sending up a rocket to collide with another missile, it ejects a mighty laser beam that virtually obliterates the opponent's projectile. This lowers the debris caused by the blast and makes the area underneath the explosion a lot safer. The Iron Beam sure sounds formidable, but is it safe to use? No weapon is 100% safe, but the Iron Beam is much safer than some of its traditional rocket defense counterparts. By now, you already know the weapon uses laser technology. However, it doesn't use just any laser. The Iron Beam runs on so-called solid-state lasers, which focus beams using lasing mediums. This lasing medium is a type of solid crystalline substance that's much safer to operate than liquid or gas weapons, because the IDF doesn't have to use hazardous chemicals to operate the Iron Beam. Solid-state lasers have always been safer than gas and liquid solutions, but up until recently, they weren't strong enough for military applications. The spearheads of solid-state laser technology came up with several breakthroughs in the 21st century to address this concern. Nowadays, these lasers can consistently engage and deal with targets, which is exactly what the Iron Beam does. Given all the incredible features of the Iron Beam, one might say that it will undoubtedly replace the Iron Dome. Still, the technology isn't perfect. You need to consider the downsides of the Iron Beam to figure out whether it'll take Iron Dome's position. The first of which is the relatively low-power design of this defense mechanism. Yes, you heard that correctly, the Iron Beam isn't as powerful as some other man-made weapons. For instance, you can now find 300 kilowatt weapons that can annihilate even the most robust rockets or knock them off course. But the industry has even more powerful weapons. There are also 1,000 kilowatt lasers that can easily engage hypersonic or ballistic missiles, allowing militaries to use them to devise the most effective defense strategy. In fact, these projectiles are so powerful that they can burn through the fuselage. Don't get us wrong, the IDF's Iron Beam is potent, but it can't compete with the destructive power of big guns. For this reason, it's not appropriate for all defense duties, such as taking down large drones and missiles. It's more suitable for standard mortars and rockets. Now you might be thinking, the Iron Beam is a laser weapon. Don't lasers evaporate anything they hit, regardless of their power? Lasers destroy their targets through heat transfer. The heat of a laser passes onto the object, making it burn. The speed at which the target burns depends on the laser's strength. In this case, the Iron Beam's 100 kilowatts aren't enough to vaporize massive targets. In 2020, various tests proved this by observing how long it took for certain weapons to wipe out small airborne drones. The testing featured a slightly stronger weapon, 150 kilowatts, than the Iron Beam. Even so, it took the weapon about 15 seconds to vanquish the target. Since the Iron Beam isn't as powerful, it would take even longer to obliterate large drones and missiles, giving some projectiles plenty of time to reach the ground and potentially cause massive damage. Next, you need to consider atmospheric scattering, which is essential when discussing any laser weapon, not just the Iron Beam. Atmospheric scattering refers to the disturbance created by sand, water vapor, salt, air pollution, smoke, and many other impurities, all of which make the laser less effective at long ranges. So far, the Iron Beam hasn't overcome this hurdle. It can destroy targets up to 4.3 miles away. Anything longer than that, and the ion beam will likely fail to disable the projectile before it hits its target. That's not to say the ion beam and other lasers can't be used at longer ranges. For instance, the IDF can utilize the technology beyond 4.3 miles to dazzle, blind, or otherwise distract the optical sensor of a satellite, weapon, or airplane. Once this happens, the target of the laser may no longer be able to receive data that guides it to its intended destination, rendering it virtually useless. But if total destruction of a rocket or mortar is the only mission, 4.3 miles remains the threshold beyond which the ion beam cannot achieve success consistently. Another drawback of the ion beam is that it's susceptible to thermal blooming. If the weapon fires in the same direction for a few hours or even minutes, it raises the temperature of the surrounding air. Ultimately, the heat can cause the laser to defocus and make it vulnerable to hostile projectiles. Now, thermal blooming isn't a major factor if the ion beam engages its target at a particular angle, but when there's a heat-resistant missile that's headed straight at ion beam, the lack of focus puts the weapon at a greater disadvantage reaching its destination. The good news for IDF is that mortars and rockets used by Hamas don't have extraordinary heat resilience, but this doesn't make the ion beam immune to more advanced rockets. Thermal blooming, atmospheric scattering, and some other shortcomings elevate the need for impeccable beam control. The laser also needs to have a clear line of sight with the target to be effective. This brings us to yet another flaw of the ion beam. It's hard to use. Many more years of testing are required to polish the technology and make it more user-friendly. The IDF, Rafael, and other spearheads will also need to work around the weapon's limited effectiveness at long ranges. Therefore, it's safe to say that the ion beam won't replace the Iron Dome, at least for now. Israel has accelerated the development and research behind the technology due to the ongoing conflict with Hamas, but even the most optimistic forecasts say the ion beam won't be deployed before 2024 or 2025. Although the Israelis have expedited the development of the ion beam, it's only natural to think that, considering the urgency of the ongoing crisis, they would have already approved it for warfare use. That hasn't been the case for several reasons. The primary challenge is technological. More specifically, the developers struggled for many years to generate a 100 kilowatt beam that could quickly destroy its targets. They saw that it was hard to concentrate this much power into a single beam and maintain its velocity. But they came up with a brilliant solution to divide the laser into multiple beams. This ensured enough power and speed, giving them the best of both worlds. However, splitting the beam into several smaller beams is no easy feat. The scientists had to fine-tune the timing of each beam, so it would work in unison with the other beams and heat enemy targets rapidly. Only recently did the IDF overcome this obstacle. Another and perhaps even more important reason is regional instability. Since 2019, there's been constant unrest in the Israel-Palestine relations. To make matters worse, Israel has had many short-term governments that prioritized different policies. All this was reflected in the military budget. The state simply didn't have enough money to speed up the ion beam production further, which is why they postponed the development. While you may have seen videos of the ion beam in action, none of them actually show the laser weapon. Some display the Iron Dome batteries intercepting inbound rockets that make the camera lens flare, which appears like a laser on screen, while others use edited footage from warfare video games. Whatever the source of those clips, one thing's for sure: as of today, the ion beam isn't being used to defend Israel from Hamas missiles. When it finally makes its appearance, it won't replace the legendary Iron Dome. Instead, it's designed to be employed side by side with the existing technology. How exactly will the two technologies work to destroy rockets, missiles, UAVs, and other aerial threats? The answer is pretty straightforward. You need to consider the design and intended purposes of the Iron Dome and the Iron Beam. Once the two systems operate side by side on the battlefield, the Iron Beam will primarily deal with short-range projectiles, including standard rockets and mortar bombs. It should also be heavily used for intercepting UAVs and drones. That's because these aircraft have light shells, which are typically made of heat-sensitive materials such as plastics. The minimal heat resistance makes them sitting ducks for the laser beams, since the beams can cut through them like a knife through butter. Basically, the ion beam can vaporize these targets in milliseconds. Another factor that will determine the roles of the Iron Beam and the Iron Dome is the distance. Since the Iron Beam is only effective at ranges up to 4.3 miles, it won't be used to intercept distant rockets, missiles, drones, and UAVs. Likewise, it's less effective in cloudy weather, because this makes it harder to maintain accuracy. The same goes for mist, haze, and other atmospheric elements. which can compromise the system drastically. With short-range, lightweight targets eliminated courtesy of the Iron Beam, the potential of Israel's enemy to inflict massive damage is drastically reduced. Nevertheless, long-range, heavy-duty missiles remain. That's where the Iron Dome comes in. As it's designed to destroy projectiles up to 43 miles away, it's much more effective than the Iron Beam at long ranges. The moment it identifies a rocket within its radius, the weapon intercepts it with a missile of its own, vanquishing it before it gets dangerously close to the ground. The short-range, long-range dynamics is where the power of the Iron Dome and Iron Beam is most evident. If the hostile launches thousands of rockets in quick succession, the Iron Dome can intercept about 90% of them, but some are bound to bypass the system. The Iron Beam supports the Iron Dome by vanquishing any projectiles that enter its 4.3-mile radius, which increases the overall efficiency of Israel's missile defense network. So, the Iron Dome will need to bear the brunt of assaults due to its effectiveness at longer ranges. But the quality of the projectiles is also important. Whenever an Iron Dome interceptor reaches the foe's rocket, it destroys it instantly. Unlike with the Iron Beam, this process doesn't span several seconds. Even if a missile has a thick metal housing, it's no match for the Iron Dome. The Iron Dome-Iron Beam duo should get things done most of the time. However, Israel wouldn't be one of the top 5 militaries in the world if it had just 2 systems in its missile defense strategy. The 2 weapons are mighty, but they won't retire other networks in the IDF's arsenal. Consider the Arrow 3, jointly developed by the Israel Missile Defense Organization and the United States Missile Defense Agency. Arrow 3 is part of the cutting-edge Arrow Weapon System, AWS, the first ever anti-tactical ballistic missile, ATBM, defense network. Arrow 3 detects, monitors, intercepts, and obliterates enemy TBMs with a variety of rockets over a massive surface, enabling the system to protect many population centers and strategic assets, using hit-to-kill technology. It launches a missile that contains a kinetic kill vehicle vertically, and whenever necessary, it changes the trajectory of the projectile toward the calculated interception point. Only upon identifying and getting close enough to a hostile warhead does Arrow 3 launch the kill vehicle. The range of the system is nearly 1,500 miles, and it can intercept weapons at heights of up to 60 miles. Another essential part of Israel's defense system is the colorfully named David's Sling. This weapon is also designed to intercept projectiles fired by Hamas or other enemy countries, including Syria and Iran. The range of David's Sling is approximately 160 miles, which is longer than the Iron Beam and the Iron Dome, but shorter than the Arrow 3. This makes the system ultra-effective at toppling mid-range projectiles, enabling it to reduce the pressure on the Iron Dome and the Iron Beam by annihilating rockets before they enter the radiuses of the 2 systems. And it might be best to end the debate on this note. The goal of the IDF when developing new defense systems isn't to replace a weapon that's already proven its effectiveness. The goal is to support the existing arsenal and create a virtually impregnable layer that not even the most intense rocket assaults can breach. That being the case, the Iron Beam will not replace the Iron Dome anytime soon. It'll mainly intercept short-range projectiles, UAVs, and drones if they make it past the Iron Dome. But at the end of the day, who knows what the future holds? Hamas may make Israel overhaul its defense strategy. If that happens, what do you think the roles of the Iron Dome and the Iron Beam will look like? Will the 2 weapons complement each other? Or will the IDF need to develop an even more advanced solution to destroy hostile rockets? Let us know in the comments, and don't forget to subscribe for more military analysis from military experts.